Hello. For this problem, we want to use the hypothesis test for proportion. And it's stating many investors and financial analysts believe the Dow Jones industry gives a barometer of 9 of 30 stocks. On this basis, a financial analyst claims we can assume 67% of stock trade in the New York went up. So for the study, we would use a test for proportion because it's proportions. The null hypothesis is proportion, so this will be P, and it will be equal to the 0.67, 67%. And this should be equal to. Yeah, sometimes they use greater than or equal to or less than or equal to if you're testing. So you're testing greater than, they may use less than or equal to, but proper, this should always be equal to. But there are some where they use the other. And then it said, we're testing it's significantly smaller. This and this will always be the same. This should be less than, greater than, or not equal to. Since we're testing significantly smaller, it's less than. Now to find these values, we plug in this gray box. Level of significance is right here, 0.025. Sample size, 91, a sample of 91 stock. And it showed 53 went up. 53 went up. Population proportion comes from the hypothesis, 0.67. Test statistic is right here, the negative 1.777, right there. And then the p-value comes here. Because this is less than, it's a left, 0.0377. Well, they're going 0.0378. Then we want to check the p-value at alpha. Well, the p-value is 0.037. Alpha was 0.025. So the p-value 0.037 is greater than alpha. If the p-value is greater than alpha, we fail to reject. And it tells you it right here. P-value is greater than alpha, fail to reject. The final conclusion, the sample data suggests that the population proportion is significantly smaller or not significantly. Since we failed to reject, it's not significantly smaller.